Before performing any kind of work on the Avalon inverter, please make sure that the DC switch is in the off position, inverter switch is in the off position as well, and that the rapid shutdown device switch is in the off position too. You kind of rotate it counterclockwise and it moves almost away from the inverter. To get to the power connections and communication connections, we need to remove the bottom half panel of the inverter. So let's do that right now. We're going to remove these 4 screws right here, and the panel will just kind of come off. And voila, the panel is off, so you can see the internals. So inside the inverter, you'll see multiple interconnection points. So here you see where the DC coupled PV connects. So this side is positive, this side is negative. So string 1 would be PV plus, PV minus here, 2, 3, and 4. You also see the connection point for battery plus and battery minus. You see the connections for the communication. This entire thing is the communications board. And you also right here see the ground bar. This is inverter load ports, and these are inverter grid ports. And you see right here we have neutral, L1, L2, and we have L1, L2, and neutral here, and also primary ground. We are not actually putting this system into operation or anything, so I'm going to use the simple cables just to show you where and how to connect the cables. Other than that, yeah, there are not going to be any conduits or real-life cables. So if you notice that some cables are thinner than they're supposed to be or thicker, don't mind that, because yeah, this is just a simple demo system that I'm using to show you the connection points rather than actually preparing it for commissioning and operation. First, let's connect the battery plus and battery minus. To do that, first we need to remove this white plastic piece here. This is where the conduit would go, but again, since this is a demo unit, there is no conduit. So now we are ready to put the cable through. The way the mechanism works is that you have the battery plus and battery minus here, and these orange buttons for each. So you push in this orange button and it releases the tension, so you can slide in the cable, and once you release the button, it latches onto it and holds it in place. So first let's bring through the cable. Okay. So this is the cable, and again, see, it's not letting the cable in. So what we're going to do is give that little button a push. So pushing it in, and the cable slides in, and we'll release the button, and see, the cable is in place. We're going to do the same thing with the negative now. And negative is in place as well. The thing to note here is that I'm not going to connect the PV cables here, these ones, but they have the same principle of operation. You just push it in and it releases the mechanism. You let it come back, and it grabs the cable, and the cable is securely in place. Now let's focus a little bit on the communications. I'm going to relocate the camera and we can talk about that as well. You notice that this communication cable right here is disconnected from the factory. So you keep it disconnected because the communication cables that we're using, they take care of the type of communication that this cable establishes, so no need to connect that. Let's put this cable out of the way so it's not in our way when we're trying to interconnect the other communication cables. So let's put it aside somewhere. For now, let's place it here. Let's also remove the plastic piece right here so the communication cable can enter here. Now we have this plastic piece removed here, and obviously we are connecting the communication cable or cables to the inverter, and the logical question would be to ask which communication cable. Now you may have already noticed, or you may already know, that the way the Avalon system works in terms of communication is that battery communicates to the inverter. That's one cable. Battery communicates with the SCP, that's the second cable, and the SCP communicates to the inverter. That's a third cable. So think of that as a communications triangle. So here we are going to connect first the battery to inverter communication cable, and that cable is labeled as such. On one end it's going to say battery, on the other it's going to say inverter. I'm going to show you that right now in a moment. So right here, battery, inverter. Battery side of course connects to the battery, and inverter side connects to the inverter. And you see that smaller, thinner cables inside are also labeled. So BMS CAN low and BMS CAN high. Obviously these cables land here onto the communication board. We're going to go ahead and connect these cables in place. So let's put the cable through. Oh, I'm sorry, push the camera there for a second. So, and the way this mechanism works is that either with your finger, but I rather prefer the flathead screwdriver that I have right here with me, lift up this orange thing and you will feel a spring-like tension, and once you feel that tension, it is ready to have the cable put into it. So see, it's not letting it in the cable, so I put up this orange thing and the cable slides through, and see, it's securely in place. We're gonna do the same with the CAN low, so right here, and that's it. I'm not gonna show you the entire process of interconnecting all of the cables, but I'm gonna put on the screen a small schematic / diagram, drawing, whatever you want to call it, that will be sort of a map of communication, which cable connects where. And if you need to, you may pause the video, refer to it. I'm sure you'll find it useful, or you can always find this information in the manual. Okay, so the power cable connection points. As I said before, this is inverter load, this is inverter grid. These are energized only when the grid is available. These are energized when the grid is unavailable. And I'm going to show you how to put in the cables into these connections. And before I do so, let's remove these plastics right here. Again, same principle. So this one we're going to use for inverter load. This one we're going to use for inverter grid. So starting with the inverter load, this is the same mechanism, or maybe I should say mechanism with the same principle as we saw with the battery cable connections. So you just push in this orange button in, all the way in, slide in the cable, release the button, and it latches onto the cable. We have our L1 coming in right here. We're going to bend it a little bit so it can get through. Okay. So it's not letting our L1 in, so we're going to push the button all the way inside, release place it, and that's it. Now we're going to do the same thing with the L2, and meanwhile I wanted to tell you that the copper should be exposed by roughly an inch in order to have the right length going inside. And L2 is also in place. Now we're going to do the same thing for the neutral. That's it. So L1, L2, neutral. The grid is a little different though. So the way the grid mechanism works is that right now it's in the open position. So when you put it all the way up, it's in the open position, and when you put it down, it locks and latches onto the cable. You need to put something through this, either the, I don't know, hex, Phillips, but nonetheless, I'm gonna use the Phillips in this case. But make sure that whatever you put in, it even could be a flathead. Actually, could be preferable to use a flathead, but nonetheless, whatever you put in, make sure that it goes all the way inside. Okay, so let's put the cable through. So we have our L1 through. We find the compartment in the bottom. We put it in place. Put in my screwdriver and push it down. Actually, like so. Let's see. Now it's locked in place. It's not going anywhere. Let's do the same thing with L2 and neutral. Here too, about an inch of exposed copper. Now it's time for the neutral. Okay, so that's what it looks like and what it's supposed to look like.